I have, since I started my education for civil engineering, I've just heard two compelling variables that need to be kept in mind is budget and time. And
Yeah.
everything needs to be within budget and time. And I think one of the major benefits of adopting automation is respecting those two variables to a greater extent. It is the biggest benefit is developing these trustworthy deliverables within a quick time, and it gives us an additional level of flexibility to deep dive for any further analysis once you have the basic deliverable ready. So design automation is an exceptional opportunity for a young to mid-level engineer to understand the engineering concepts and deliver the project efficiently. Aspects of design processes like sensitivity analysis, understanding the concepts for a young to mid-level engineer, it becomes way lot easier with automation because one is just not struggling with making or drafting a new spreadsheet for every single project, and the whole process just becomes more efficient in the sense that we start focusing on building in or bringing in additional details into our deliverables. So I think that's one of the biggest benefits that I've come across. And in terms of limitations, obviously there is this limitations of most of the times it becomes, again, coming back to budget and time, it becomes a bit impractical to invest that level of capital and time on projects, especially on projects with tight deadlines and heavy workloads.
Hi Rajat, welcome to the Digital Construction Podcast. How are you today?
Very good. Thanks, Andrea, for having me over.
So today on the Digital Construction Podcast, we dive deep underground, really, literally and digitally, because we are here with Rajat Gangrade. He is a technical advisor at HNTB. He's also co-founder of Ground Up. It's a startup. I'm very excited to learn more about it. And Rajat also previously worked at Arup, at AECOM, so he has a lot of experience. And at the moment, he's in North America, in San Francisco, and very excited to talk about all of the aspects of tunneling and geotechnics, but from the digital point of view. So this is a very exciting episode today. So to start today, Rajat, I would like to talk about this concept of digital first approach for tunneling. And many of the people that don't work in the infrastructure sectors may not be familiar with it. But can you share with us a little bit of what are the aspects that can be digitized in the context of tunneling and infrastructure projects?
Yeah, interesting question. I typically like to break the projects into different phases and different cycles that the project actually goes through. So during the design and planning phase, I think a lot of emphasis is on digitizing the archive data, be it geotechnical data or be it the data from desktop studies, and those are typically archived or digitized in the sense in terms of building preliminary digital twin models or preliminary visualization models that exist for the planning phase. And BIM is a good example of it. You as an engineer want to visualize the utilities and the structures and what environment your project is typically set up in. So this planning phase really helps with understanding clash detection with the utilities and what sort of obstructions we might be facing in terms of alignment optimization. That's the first phase. The second phase is more towards the detailed design phase, where engineers take a deep dive into what exists and they start building tools that encompass bringing in GIS aspects and then bringing in the actual footprint of the structures along the tunnel alignment and bringing in the 3D geological model. So it's basically creating a single source of truth or a common data environment for different data sources. Those are some of the striking, or I would say key features when it comes to digital aspects and tunneling. But the most interesting part comes during the construction, where we have actual construction data being read by sensors, be it the tunnel boring machine or be it the data from instrumentation and monitoring. All of that integrated into maybe a digital twin or single piece of software, and all this data is transported to an environment through cloud-based solutions. So that's another key striking feature of digitalization during construction. And the last part of it is the operation and maintenance part, where once the structure is complete, we want to create an archive of the project in a way where it becomes easier to track and record any predictive maintenance and incident logging. Sometimes we do a very sophisticated version of inspection of the tunnels using automated tools or robots nowadays that capture the interior of the tunnel as singular images, and then there are machine learning algorithms that they utilize to understand, which part of tunnels are experiencing some sort of water leakage or crack detection. So that helps with the automated documentation of the as-built conditions of the tunnel, and then all of that is typically stored with the project stakeholders. So yeah, I mean, digitalization has its own use case in every phase of the project. Depends on what part of the project we are in, but I think it has a tremendous amount of application during the construction phase of tunneling.
No, it's great to hear all of the opportunities we have. And one of the things I've learned over the years working in this digital space for the construction industry is that different regions may have different level of maturity. And I'm based in Australia, I'm in Sydney, you are in San Francisco in North America. So I'm just keen to know from your point of view, how digitally mature the tunneling sector is in North America.
Yeah, that's a very insightful question. While from what I see, I think Australia is way ahead of North America. Just to mention that, I think in terms of when it comes to digitalization during construction, there are a few contractors over here and consultant companies over here in the US that are pushing the envelope on adapting digital technologies to advance their practice. However, I would say I would still rate the maturity level to be relatively low, and it's lower than I expected, to be honest with you, in the era of 2025. And over the recent years, there is good amount of awareness. However, the practice in North America, I think, faces some aspects of barriers as well. The conservative industry culture. There's quite a bit of inertia on adapting the technologies. There is an uncertainty on, what is the cost benefit relationship once these technologies are adapted and applied. So I would say it's an open canvas at this point in time in North America, and it presents an exciting opportunity for engineers like us to propose, build, and basically prove what these solutions can add to projects.
Yeah, it's an interesting space because there is a lot of barrier in this industry to adopting
Right.
digital technologies, but yeah, it's exciting to see how this evolves over time. And one of the things I'm always curious about, you are an engineer first, and at some point you must have decided, let me focus on the digital stuff. And I'm just keen to know, how did you develop this interest in digital rather than just applying the traditional approaches that were available for your discipline?
Yeah, it was actually during my PhD when I started exploring these tools. It was for the first time in any aspects of my career, be it professional or even personal, that I started to advance. I started to code and I started to write scripts and to automate most of my work that I did during the PhD. And it was a massive learning curve in the sense, I mean, as a civil engineer, you're trained to ask the questions how and why, and there are codes and standards to refer to, and then you go to those and you find references, and then blah, you just make it work. It's such a different field when it comes to digitalization, and when you adapt and start coding and scripting, because there are tons of resources. You need to filter out the right resource and then adapt the right optimal approach to get to what you want to do. But thankfully, there are tons of resources available online as well. So that really helped me. I saw examples of how automation is performed, how digitalization aspects of tunneling are done. I mean, there was quite a bit of limited amount of research, so most of it was my own imagination of if I want to visualize some aspect of data, how should I do it? If I want to see the statistical distribution of a property, how should I do it? And I took a lot of inspiration from other fields and other industries, I would say. Medical science was one of them because there's a lot of statistical analysis that happens in medical science as well. So I looked at those publications, I looked at those plots, and then used to figure out, oh, can I replicate similar things for geotech and tunneling industry? Um, I also, since I started coding, I also traverse this fine line of developing an application or web application or a software, and then also being the engineering brainchild behind it. But it really gets very challenging. You can either be a software developer for the application, or you can be an engineering product manager, I would say. So was confused for quite a bit amount of time, wasted a lot of time doing that, but I think it was an iterative process. And my PhD really helped me gain that level of expertise and confidence to develop and to implement such digital tools.
Yeah, sometimes it comes from the desire of solving a problem in a slightly different way, and digital is probably like the easiest thing you can find in front of you. And I loved your approach of looking at other industry or other aspects where, of course, we can learn a lot from other industry that have solved
Yeah.
similar problems. Maybe they have a mindset that they have used to solve a problem. That's also great. It's something I've done a lot as well.
Yeah.
So that's great. I would like to talk about data, because one of the things that I think are very important at the moment, it's data, and data is the foundation for all of the things we do. We talk about data ownership, but from your point of view, think about geotechnical and tunneling. What are the types of geotechnical data and tunneling data that are most often overlooked or underused?
Yeah, I think when it comes to, I think one of the most often underlooked and overused, and this may sound counterintuitive, is the data from geotechnical site investigations. I was going through some of my own work and some of the latest research on the failure incidents on tunnel projects, and sort of came across this statistic last evening that talked about that about 77% of projects in underground construction and tunneling, they suffer because of insufficient data or an inadequate interpretation of the data. So I think in what happens is we perform investigations, but that is such a low number in terms of percentage wise of the volume of the soil excavated, that it leads to a significant amount of uncertainty. And on that limited number of boreholes, we carry out further limited testing analysis or laboratory testing. So that basically reduces our sample space. And there is no spatial analysis of the data in that sense. There are no details about where should we drill more boreholes just to understand and reduce this uncertainty. I think that becomes a huge challenge. So I feel that the investigation data that we get from site investigations is is definitely overlooked, and needs to be investigated a lot more. There have been projects, as I mentioned, in North America and worldwide that have suffered because of inadequate ground conditions and not utilizing the data completely. Um, I think I think that remains to be one of the biggest challenge in terms of utilizing the data.
Mhm. And from your point of view, how can we improve the way we manage data to then overall to improve the outcomes of the projects we work on? For example, if you're working on tunnel projects, how can we improve our way to manage the data to improve the actual outcome of the projects?
Yeah, I mean, I think it all comes down to geotechnical workflows, and that is what our industry has struggled with for a significant amount of time, and for a long time. It is probably going to be a very fundamental conversation when I bring in the topic of workflows to maintain, organize, analyze, and then interpret geotechnical data. Currently, most of the industry practice is involving using fragmented or siloed data sets, and we struggle with version controls of the files. We struggle with analyzing the data in bits and pieces. It imposes a significant challenge to the engineering community. A smarter geotechnical database management system is required. Basically, that serves as an umbrella to every single step or of the workflow that we need to adapt, be it math and logical operations, be it visualizations, be it statistical modeling. The industry they must look into a system of that that starts serving as a common data environment or single source of truth. For engineers like us, when we see a comprehensive picture of the data into a single environment, it helps us understand what the gaps in the investigation are. And then obviously once you get access to smarter, leaner data, you would utilize that data to prepare leaner proposals and win projects and build, obviously utilize this as legacy applications into advancing your business. So overall, I think along with geotech database management, an aspect that is picking up some steam over here in North America is the integrated digital delivery. And it's not just maintaining the data in a database. It's not a database problem. It's more of a problem of integrating different sources of data into one single environment, and getting away from a 1000 page PDF to a single screen where you can visualize and you can see what the data is all about. So I think for me that is what geotech database management should be like.
Yeah, it's a good point. It's all disciplines are struggling with trying to integrate the different data sources from different platforms into one single place. That's a difficult thing to solve at the moment.
Right.
One, you touched previously on the uncertainty related to the specific of your discipline of geotechnics.
Yeah.
So sometimes you have to work with the unknown, and you have to think about the variability of the space and the uncertainty. So how do you, because you may have unpredictable surfaces, you may have done samples only in specific places, but
Mm-hmm.
you don't have all of the information, which doesn't, like, from engineers really don't like uncertainty too much, and digital tools also
Right.
don't like uncertainty too much. So how do you
Right.
integrate this uncertainty into your design process?
Yeah, that's a great question. That was my PhD was all about. So I think the idea that we are not able to excavate 100% of the ground, and despite that fact, um, we are fitting in an engineered system into the ground for a period of 120 years. It just amazes me. It just the kind of risk that we take as engineers to excavate tunnels and build these systems is phenomenal. So when it comes to integrating uncertainty, I think it's imperative in the first place. And second, there are robust approaches. As I would say, probably 40 years ago, what someone would have done was change one number and see what the change in output is. And that is a very fundamental way of doing things. You change something, you see what the output is. You change something again, and then you change a combination of parameters, and then you see what the output is. Later on, this was advanced a little bit to something what we call as Monte Carlo simulation nowadays, which is using a statistical distribution, and you do 1,000 iterations of it, and you expect that the true value of a parameter would just lie within that distribution. And at some point in time, you will hit the true value, you would get the output, but you would also get a standard deviation on the uncertainty. And that is how uncertainty is quantified or uncertainty is integrated into design procedures. My thesis talked about more sophisticated approaches on using stochastic algorithms that quantify the variability mathematically and capture the pattern of variability of geotechnical data. Variability measures such as standard deviations, interquartile ranges, those are extracted and those are then translated into the determination of parameters. So it was more around looking at what the statistical distribution of the data was, and how mathematically the data varied from one point in space to another point in space. And this sort of created the opportunity to build probabilistic approaches or probabilistic methodologies where we have multiple possibilities or realizations of the ground conditions and what would that lead to in terms of capturing the uncertainty in a parameter. In a very simplistic way, as an example, if there is an uncertainty in a geotechnical parameter that affects the tool wear on the tunnel boring machine, um, then we would be able to translate that uncertainty into the risk of tool wear and basically see what is the uncertainty in the tools wearing out eventually. So it's all about capturing the variability in the soils, which is just inherent because of the way the geological depositional processes take place.
And do you use any specific tools to make informed decisions with uncertain data?
Well, yeah, I mean, there are a bunch of tools that are available. Geotechnical industry has over the years relied upon using autocorrelation functions. In my PhD, I started to use geostatistics that was based on stochastic algorithms to derive and quantify this uncertainty and then translate it to quantify the level of risk. Another level of tools that I would think that would be used to communicate uncertainty to project stakeholders and helping them make informed decisions would be um, engaging, compelling visualizations. Just imagine having a visualization with a heat map of a certain risk projected along the plan view of the tunnel alignment in an urban setting. That just gives a clear indication to the stakeholder on what areas of the project are experiencing risk or what may not. So I think visualizations, they convey the probabilistic measures and help a user intuitively understand the results with a threshold of risk obviously being defined. These visualizations, as I said, they can be confidence intervals, they can be heat maps, they can be cumulative distribution functions, they can be probability curves. But yeah, I mean, uncertainty and spatial variability, I think both are conveyed better through visualizations than just quantitatively.
Yeah, definitely. And yeah, you can see how the different aspects of digital can help solve problems, but also inform stakeholders, which is great because sometimes within
Yeah,
digital, to even to manage expectations of the different parties involved, it's key. Um,
right.
one aspect one buzzword I should say, it's automation. We've used this automation word for a long time now in the industry, and but it's real. Like things can be automated,
Right.
processes can be improved.
Yeah.
I just wanted to ask you, from your point of view, if you've seen any examples of automation in geotechnics or tunneling.
Yeah, the word automation really gets me pumped up because it is such a low hanging fruit in terms of implementing in tunneling. Is it just presents a significant amount of opportunities. Although being a low hanging fruit, not many have thought about advancing the industry practice in the sense of automating routine tasks. So I think examples of this particularly includes bringing about efficiency in design processes, or includes speaking to software using codes and scripts, or allowing one software to speak to other software, and then there is interoperability of data. um, or even something as basic as building robust repositories and design libraries that contain a variety of calculations. Something that I have come across at Arab before, where most of the design calculations are stored in libraries, and they help automate the routine calculations on every single project. But another example that I came across fairly recently, I think from the Australia Tunneling Society, was using numerical modeling tools like Plaxis and FLAC, using Python, and it's just amazing how one level of scripting is helping run a lot of cases to characterize and quantify the uncertainty in the tools, in the results. So I think that example of automation was really phenomenal. I would like to personally implement it at some point in time. And as you must have already guessed it, my interest lies in building or developing these library of solutions for analytical calculations. I believe every company, every contractor, every community, everyone part of the community should be advancing the industry in that direction. Where the human intervention is minimal, there lies quite a bit of challenge in maintaining the appropriate data structures, and then QA QC for people, senior professionals who are not well accustomed with automation. They would struggle with the QA QC aspect, so it needs to be bared in mind. um, but again, I think in the current state of practice, automation should be directed more towards bringing in data from different sources, and then automating your typical regular workflows. And when I say different sources, as in an example of automation could be geotechnical parameters, project constraints, tunnel geometry, what is the impact of tunneling on nearby structures. So that really helps paint a very comprehensive picture in terms of automating our workflows and automating our tasks.
Yeah, I love your approach of trying to work together, all of us, to improve the industry and with automation routines. It's something that this podcast is also trying to do, trying to share knowledge.
Yeah,
So we overall achieve a better outcome for everybody, rather
right.
than developing and improving in different silos, everybody in isolation. One of the aspects of automation tools, I've been speaking about these automation tools and processes and workflows with many people over the last many years. And one of the
Yeah,
challenges
yeah,
is adoption, because sometimes people struggle to see the benefits and also even the limitation. It's also important to understand the limitation, because I always find that there are people that don't see the benefits, they don't want to accept, they don't want to adopt anything. There are
right.
also people that are overexcited and they don't see the limitations, so they expect something incredible. and but then
Yeah.
they get a little bit, they end up a little bit disappointed because they didn't understand the limitations of the tools. So from your point of view, what are
Right.
the benefits and the limitations of adopting these automation tools?
Yeah, I think since I have since I started my education for civil engineering, I've just heard two compelling variables that need to be kept in mind is budget and time. And
Yeah.
everything needs to be within budget and time. And I think one of the major benefits of adopting automation is respecting those two variables to a greater extent. It is the biggest benefit is developing these trustworthy deliverables within a quick time, and it gives us an additional level of flexibility to deep dive for any further analysis once you have the basic deliverable ready. So design automation is an exceptional opportunity for a young to mid-level engineer to understand the engineering concepts and deliver the project efficiently. Aspects of design processes like sensitivity analysis, understanding the concepts for a young to mid-level engineer, it becomes way lot easier with automation because one is just not struggling with making or drafting a new spreadsheet for every single project, and the whole process just becomes more efficient in the sense that we start focusing on building in or bringing in additional details into our deliverables. So I think that's one of the biggest benefits that I've come across. And in terms of limitations, obviously there is this limitations of most of the times it becomes, again, coming back to budget and time, it becomes a bit impractical to invest that level of capital and time on projects, especially on projects with tight deadlines and heavy workloads. It takes me back to this amazing XKCD comic that amusingly talks about investing a significant number of hours developing an automation process to be used only once a year. So it all depends on how many times we are going to use this process, and it becomes a bit challenging convincing the senior leadership or senior management in many companies that automation can bring about an efficient experience for them. So and obviously there is inertia. Obviously there is conservatism within the industry. Many organizations they still rely on legacy systems or manual processes, making the transition to automated workflows difficult. So I do see that there would be some sort of inspiration or motivation for these companies at the start of their financial cycle to adapt to these technologies, but sometimes the cost just drives them away. So that's a major limitation of automation. I mean, it's something that cannot be embedded into the current scheme of things for any company's organization or workflows very easily. It can't be done like that. There needs to be a proper vision. There needs to be a proper procedure in order to make it most useful to yourself.
Yeah, definitely. And when you think about the adoption of these digital tools, sometimes I see teams that want to adopt something because they, on one side, they think it's a good idea. On the other side, they want to deliver a better outcome for the projects. But sometimes
Yeah.
they don't think about the prerequisites of how they need to be ready to be able to adopt automation tools. But from your point of view, what are the prerequisites so teams and projects and companies can actually adopt automation tools or processes?
Yeah, that's a great question. The question actually leads to the aspect of lacking any standards or guidelines as such on developing such procedures or workflows. And every company will have to identify their own prerequisites and um, that suits them the most, be it within their workflows or be it creating a robust infrastructure. It depends, but according to me, some of the important prerequisites for implementing automation within workflows is digitization of the data. I think that's the most fundamental requirement. Appropriate database management. There should be a standardized process that is developed within the firm that helps them QA QC the outputs for project deliverables. I think QA QC is the part where the automation gets hurt the most because of the lack of communication or a barrier of communication between the teams of all right, you have implemented this, how do we check this, how do we check it for various cases. So I think QAQC is something that can be standardized. There should be strategies on how data will be brought in and how data will be output for project delivery. And these are all housekeeping items, I would say, but they create such a massive difference to bringing in the aspects of automation within the companies. And I think one of the most important one is having sustainable skilled workforce. We are struggling with that quite a bit over here in North America. But again, I think it is a problem that can be solved. The incoming workforce is generationally talented, I would say, in terms of adapting digital tools, are more tech savvy. So we need skilled workforce that will be capable of implementing modern practices. There needs to be a multidisciplinary coordination. For example, the geotech and the tunneling team needs to talk to the numerical modeling team or someone who's doing more automation on cloud computation. And then therefore they need to have communication with software developers. So I think the prerequisites are more on having some sort of standardization within the firms to help them make most use of the automation.
Yeah, definitely. And at the moment, we live in the AI era. So this is the time for AI. Like previously, we were all talking about automation. At some point, somebody started talking about blockchain, not so much in the construction industry, but it looks like it's the time for AI. It's very hard at this point in time to understand what is the role of AI in the construction industry in general. And if you try to focus on one specific discipline, it's probably even harder to understand how AI can improve the specific workflows. But I'm just keen to know your take, to know your take, your point of view on what the role of AI in the construction industry at this point in time.
Right. Yeah, I think it's extremely challenging to quantify that because there is a lot of noise. There is tremendous amount of noise on AI, and you see stuff that possibly someone has developed a prototype and are willing to implement, but then it works on one project but doesn't work on another project. And there is this another aspect of introduction of AI into the industry is through the academia. And if you look at the publications coming in from these universities worldwide, not only in the US, but even China, Australia, Europe, there is tremendous amount of noise. Everyone is just churning out papers on AI maybe every week. And those are all opaque, I would say opaque and difficult to reproduce or into the industry. So it is the responsibility of engineers like us to determine the role of AI in the construction industry. There are tangible benefits and outcomes that are possible, using AI. But it's our responsibility to find such use cases. In my personal opinion, the role of AI is to take away the heavy lifting that we do on a routine task. I mean, one does not want to struggle to write once a quick reference to something that needs introduction about a topic or has a hard time understanding. I think we should focus on using AI for these fundamental tasks first, gain confidence on how things work, and then proceed on to implementing AI for complex engineering tasks. Yes, and yes, of course. I mean, there have been cases where AI has, I mean, there have been cases where AI has been used for complex engineering tasks and has been successful as well. But I think for the major part of the community, it is easier for them to navigate into AI and find use cases just by implementing simpler things. And for professionals who love to code, I think sky is the limit. I think AI can be used to develop all sorts of engineering applications and can be embedded easily into their daily routine tasks. So I think a biggest part of AI in construction is just automating some of the routine tasks for now.
Yeah, it makes sense. And but do you think that the industry is mature enough? Because we have been debating how they're not the industry is maybe sometimes not mature for things like automation. Do we just jump straight into AI, or maybe the AI is the solution? What do you think about the maturity of the industry and adoption of the AI solutions?
Yeah, no, my opinion would come out as very startling or surprising for the most part of the community. But I don't think industry is, especially over here in North America, I don't think they are AI ready. And the reason for that is, again, I mean, there is a lack of standardized guidelines on AI, and then no one knows what the cost to benefit relationship is. There is no proven performance metrics on AI. So I sense a strong inertia within the industry to adapt to AI solutions. And I wrote about this a couple of months ago, where, and I mentioned previously on this as well, that the way the academic research is progressing is just creating more noise rather than contributing to bringing in practical applications of AI. They are doing AI research at the speed of light, 10 papers a week on an average, maybe. But where is all of these being implemented? I don't see them being implemented. I don't remember the last time an engineer picked up a journal publication and said, "Oh, this is what I'm going to implement on my project." It doesn't work that way. So a small cohort in North America is attempting to implement AI for tunnel design. Some famous applications that have been discussed in North America are on optimizing, TBM operations, and there has been a significant amount of research being done at Colorado School of Mines and UC Berkeley, and University of Illinois at Urbana-Champaign, on how TBM operations can be made more efficient. Oh yeah, I would also like to mention there has been some extensive research on the same topic in the East Coast of the US as well, where they have focused quite a bit on understanding the outliers in TBM operations using AI and then building model for structural geotechnical analysis. But again, all of this comes as a um, comes on background of some success in academic research, but in terms of practical applications, it's been a big challenge over here in North America at the least.
Yeah, it's this we are at this stage where there's this new thing, and we have to think about how to use it. And yeah, it's an interesting space to watch at the moment. Do you think that geotechnical and tunneling have any differences or similarities with potentially other disciplines when we think about the usage of AI? Is there anything we can learn from other disciplines?
Yes, definitely. I think we can learn quite a bit from what other aspects of or what other industries are implementing into their processes. But again, tunneling and geotech days, the industry is so unique, and that uniqueness comes just from the uniqueness in the projects. If we are taking an example of other industries implementing a service in AI for a particular problem statement, I think they might be seeing that problem statement on multiple projects, but that's not typically the case within the tunneling and the geotech industry. So certain aspects of design applicable in one project may really not be applicable to other projects, and we face that challenge. But again, this sets up a perfect opportunity or use case for what the tech industry is calling nowadays as agentic AI, which is basically just building an intelligent model capable of autonomously learning and adapting to the change in product conditions, project environment, change in machinery, change in construction means and methods, change in design approaches. So conventional AI or traditional AI is not the answer for geotech and tunneling industry. I firmly believe that agentic AI is the future for our industry and is a much better perfect fit for us. Um, the challenge with that is we do not have any background on it as a workforce. It's not been introduced in our curricula. It's not been we have not been trained for it as such. But I hope this challenge can be navigated with traditional AI. So we need to utilize the traditional AI as a stepping stone towards building solutions that would be focused on implementing the agentic AI that takes into account the change in project environment and conditions. Significant challenge to that would be the cross collaboration among the industries to share data. I mean, if there is no data, there is no AI. So we really need to work on that aspect as industry.
It's another example of the technology evolving faster than the industry, or
Exactly.
faster
Yeah.
than the industry can adapt to it.
Right.
But you are working on an exciting project in addition to all the things that keep you busy today, which is a
Right.
startup. It's called Ground Up. I'm very, very keen to learn more about it. It's a startup in geotechnical, for geotechnical professional, I understand. And I just want to know, what is the problem that Ground Up is solving, and how did the idea come to life?
Yeah, sure. Yeah. No, we are very excited about Ground Up. So Ground Up is our founder, James Holcomb's idea. He was working at Arab and was developing or building softwares for geotechnic solutions. And he came up with this idea of, transforming the geotechnical engineering practice with systematic database management. And um, I think I met James over LinkedIn, chatted with him about the possibilities of building an extraordinary piece of solution, and that's how we collaborated. But Ground Up is aiming to transform the geotechnical engineering practice in a much bigger way than it is carried out right now. We want to integrate database management, or I would rather say we are integrating database management, exploratory data analysis, or statistical modeling, integrating visualizations, helping engineers go from raw data to insightful data or report ready visualizations in a very short amount of time. We have sort of realized that given a period of time, in the conventional practice, engineers spend about 70% of their time just maintaining databases. And the remaining 30% is typically spent on analyzing the data, interpreting the data, looking at the distributions. But most of the time is just, oh, I created this file, let's create another file, and then, try to make one file speak to another file. It all becomes painful. So we are moving away from that. We want to get the user into a single cloud-based web application and do all their math logical operations into a single environment. And we want the user to move from raw data to, I would call as polished output in no time, with less amount of effort. So that leaves good amount of, again, time and budget to look into the details of the data or deep dive into it. That is the biggest problem that we are trying to solve. In addition to it, we are also looking into integrating aspects of ground modeling and integrating aspects of GIS mapping into Ground Up. So basically, just building a comprehensive workplace to bring in all your complex geotechnical data transform the data into something very actionable and something that is report ready for project deliverables.
This is certainly an exciting space and one to watch for all the people involved
Yeah.
in this industry. So good luck with this project, and I'm very
Thanks.
keen to see how the project evolves. And every time that there is somebody trying to improve the technology and the space and the tools for all of us, it's always a great initiative and a great, and I'm hoping you will get a great outcome for you and your team and the rest of the industry.
Thanks. Yeah.
One of the challenges we have in the industry is culture and change, and
Yeah.
how to convince people to basically adopt these digital tools. We live in an industry. This is an industry where there is a big variety of people with different ages, and there is the younger one that, as you said, they are a little bit more tech savvy. They are native
Yeah.
digital people, but we also have the most senior people that tend to be the people that make decisions around what to do in the
Yeah.
business. So, from your point of view, what are the biggest barriers to adoption of these digital first workflows, particularly in geotechnical and infrastructure projects?
Yeah, that's a very valid point that you made about the senior management making decisions and them being a bit less aware than the younger generation that's coming in. So that's really creating sort of I would say, a barrier in itself in terms of different expectations and different strategies on understand and running the business. But I think one of the biggest barrier that I have understood so far is the complexity of technology. And you brought in a really good point of technology is different to different people. And for someone in senior leadership who's been in the industry for a significant amount of time, for them, technology could just be an automated Excel sheet. But for an incoming engineer, technology could also mean, oh, why don't we use AI to just read drawings and get the outputs? So there are difficulties integrating the technological aspects into our businesses, and I think that's really a big barrier. The organizational silos, as you mentioned, I think poor communication and collaboration across the teams and across hierarchies, it creates a significant barrier. I mentioned about the huge capital investment that technology requires, and there is this pressure to deliver the projects in time and on budget. It creates sort of an environment where the teams start to think that we are better away practicing or implementing these technologies on a different project, and we'll do the digital first workflow some other time. Let's just get this project done and let's just proceed with our deliverables. So I think those still remain a significant barrier for our industry. I think we need a bit more amount of patience and a bit more amount of budget, obviously, to work through it.
Yeah, it's always the budget and the projects and the timeline that really affect how digital is delivered. But
Yeah.
we're close to the end, and I would like to focus on the future of
Uh-huh.
digital and tunneling. And what trend do you see are shaping the future of tunneling globally from the digital point of view? And if there is anything that you like, and what excites you the most about these new trends?
Yeah, that's a great question. I think as as a digital evangelist slash an engineer, I'm most excited about the virtual design and construction aspects, typically known as VDC in our industry or in the AEC industry. This is one of the top trends that will shape the advent of digital use cases in tunneling and underground construction. So, for people who do not know, VDC is basically a project management methodology that utilizes digital technologies, particularly BIM or building information modeling, to plan, design, manage construction projects more effectively. It involves creating a digital representation of the actual physical project, what I personally call as a digital archive. You like imagine once the project is done and you are served the project on a table, but in a very digital way on a screen of an iPad, probably. That is allowing stakeholders to visualize, analyze, and optimize all aspects of construction. I think what makes this unique is this approach helps us move away from traditional methods of using digital tools, and helps us uh, gain the a comprehensive story, create a real-time impact, or a real-time project representation, I would rather say. It enhances obviously coordination, and there is the aspect of improving efficiency. All of that is being said by tons of people back in the past. I'm not saying anything new, but I think it will get to a point, especially in the tunneling field, it will get to a point where integrating a variety of data into a single environment helps us achieve the VDC, and it's going to be a phenomenal use case for our industry, and that is definitely the future. We want project stakeholders from different disciplines, different backgrounds to come together to work together and solve problems that are typically solved in silos at this point in time. So I sincerely hope that engineers like me and like yourself and like everyone else, they harness the strengths of virtual design and construction in preparing excellent solutions for most complex and challenging problems. This could rather be like a technical solution to refine the builds or build economically sustainable projects. Again, it's an open canvas, and engineers like us, we define the problem statement in that sense. But I think VDC is the future.
Yeah, that's definitely we really hope for that. And where do you see the industry in the next 5 to 10 years? Because you're describing a future that we really hope we will achieve. But
Right.
if we try to stay a little bit more practical and think about what's a little bit more tangible, the next, like it's kind of like a short, medium term, maybe for the industry.
Right.
Yeah, 5, 10 years. Where do you see the improvements?
Yeah, no, that's a great point. I think over the next 5, 10 years, we are probably going to see a growth worth, I would say, 20 years because of all the possible integration of um, agentic AI and explainable AI and digital twins that would happen. There is great amount of awareness and great momentum at this point in time within the industry to understand these terminologies of digital twins and integrating geotechnical and instrumentation data real time for real time monitoring. There is good amount of awareness in terms of how these tools will help make data driven decision making. So I think over the next 5 to 10 years, digital twins and virtual models are going to really pick up. And as an industry, I feel we are, and I hope that we are going to make significant advancements in adapting these technologies for sure. Um, Cloud-based collaboration is something that is going to happen or is expected to happen at least within the next 5 years. Companies will slowly go through the process of raising the bar on their infrastructure for cloud-based collaboration, and this would be one of the first steps to take to integrate data from different sources and different softwares and different data structures. So that really is going to be a problem solver for us. And I think the last part is within the next 5, 10 years, I mean, the digital literacy of our industry is going to go up significantly. The incoming workforce is hugely talented. They probably are exposed to more opportunities and situations than we could ever imagine. So I'm pretty confident that the incoming workforce would bring in that fresh breath of air and help us empower the digital aspects that are possible within the tunneling industry. Um, so yeah, I mean, I'm pretty excited for what the next decade holds, because I see a significant amount of growth than what has happened in the past decade or so.
Yeah, thanks, Rajat. This was a great episode. We are at the end of the episode for today. If people want to reach out to you, where can they find you?
They can find me on LinkedIn. I'm there with my first and last name. I can also be reached over email at rajatgangrade@gmail.com. But yeah, no, hit me up.
Thank you, Rajat. It was a great episode. Thank you.
Thanks, Andre.